I'm going to show you how to test normality using Excel. To do this, I will do a normality test called chi-square goodness of fit test. This is an objective test compared to the PP plot, which is somewhat subjective. So let's go ahead and start it. I have this data from our emission lab, emission testing center, carbon dioxide emission data. The emission level, we do a lot of analysis with that. Before doing any analysis, we need to double check that, make sure that the data is normally distributed. So to start with any data, I would like to have IDs for these data points, because in case if I have to go back to the original data, in case if I sort or do anything, I can always go back. To do a normality test, I need to calculate first few basic statistics. For example, sample size. I can use a function called count function that will calculate the number of cells that has numerical data in there. So it will ignore that carbon dioxide title cell, and it will count everything else from the cells where we have numeric data. Now I need the minimum value. So minimum, and then I need maximum value of the data. I need the range. In Excel there is no direct function for calculating range, so we'll have to use mean and maximum value to calculate the range. Of course we can do descriptive statistics to find out all these. However, I like to do it this way. So minimum, if you type min and then select that column, it will give you that minimum, and max function will find out the maximum value. And the range, we can simply subtract the minimum from the max. This will give our range. We also need cell length. Now there is a formula that we need to use to calculate cell length, which is, the formula is R range divided by 1 plus 3.322 log n, and then close the parenthesis. So let's type that formula here to get the cell length. This is range divided by the 1 plus 3.322 times log n, which is the sample size, close the parenthesis. So that's my cell length. Now I can calculate from that cell length the number of cell that is actually I need number of cells to do the normality test. So number of cells, if I know the length and range, then I can calculate the number of cells. Let me show you using the pen is not working for some reason, but that's okay. Let's do then the range divided by the cell length. That will give you my number of cells. Now I can't have a fraction number of cells. I need to have a I got it now. So I have this normal distribution, for example, like that. So what I'm going to do, so this is my minimum value, for example, correspond to that, and say this is my max value, correspond to this number. So my range, I can simply just max minus mean to get the range value. Then I'm dividing these by 8 different cells. So I'm dividing by 8 cells. So my goal is to find out what is this cell. So let's go ahead and so I got 8 cells total. So I'll have to recalculate the cell length. I would say corrected cell length would be equals range divided by my number of cells. I also need mean value. In Excel I can type the function called average to get the mean value and select that column. And standard deviation, I can type stdev.s for sample, p for population. I have a quite big sample, 120 data points, so it's not gonna be a big difference between sample and population. Now I need each of those cells start and finish. So for example, first cell, then second cell. Let's see if I can copy that. I have total 8 cells, so I need this cell start and cell end, and the probability already under the curve in that cell. So cell start, you start from the minimum value, and then the first cell ends the minimum plus the corrected cell length. Now I'm going to be using this cell length again and again, so I want to freeze that. If we just press F4, this will freeze that D7 cell. If you are using Apple, this F4 will not work, so you have to type $ before D and after D. So this $ before D will freeze this column D, and $ before 7 will freeze this row 7. Okay, now the second cell will start where the first cell will end, so I just going to copy that value and then copy this all the way down. So I got all cell end and cell starts. Now this number should be the max value. That's where my data ends, and this is exactly the same value as my maximum value, as you can see. That's good. Then now I want to calculate the probability between the area under the curve here. So probability between this line and this line, so area under the curve of this. So let's go equals, there is a function in Excel called normdist. That's a regular normal distribution function, normdist, then x value, comma, mean value. I'll be using mean for, I want to calculate probability for all of these cells, so this mean and standard deviation will be used again and again. So I want to freeze that, comma, standard deviation, freeze that, comma, and I want cumulative probability. So what I want is probability all the way from the back, because normal distribution does not touch x-axis. So I want probability all the way from the back up to this point, and then I will subtract this probability all the way from the back. So let's do subtract that, normdist, and then x value, comma, mean, freeze again, comma, standard deviation, freeze again, comma, and then cumulative. This is the probability of this area. This is the area 0.018. So I'm going to copy all the way down. This should add up to very close to 1. It's not gonna be exactly 1, however it should be very close because we are not taking any area before that or after that, so it's close enough, 0.97. Now I want to calculate how many data points out of that 120 data points should be within this area. So my expectation based on the normal distribution is expected frequency E. My expectation based on the normal distribution, I can calculate that by just simply multiplying this area under the curve times the total sample size, because the probability of any of these data point could be in this area is 0.018. Then if I have 120 data points, I can simply multiply but to get that values. Now something going wrong here. Okay, I need to freeze that 120 because I want to use that again and again. Same sample size for all of these values. Now the total should be very close to 120, but as you can see our previous probability sum was 0.97, so it's not gonna be 120, but very close. That's reasonable. We're missing only 3.5 data points. Now I would like to calculate the observed frequency. Now I need how many of them are in fact in the data so in this cell B, the one we collected from our emission research center, I want to see how many of them are observed in this area, first cell for example. So to get that, I can use a function called COUNTIF in Excel, and then select that B, so it will count using some condition this entire column. If a condition meets, then it will count that value. So my condition is I want to less than or equal to, and then ampersand. If I have to use a cell, this will count all the data points up to this point including that data, minus COUNTIF this cell, comma, and then this ampersand this cell. This will calculate all the data before that. I know there was no data, but I was trying to make a general formula so that we can calculate this. Okay, I need a alright, so it looks like I have 3 data points in the first cell, and if I copy all the way down, it's gonna count automatically the number of data points. This must be equal to 120 because we are just counting these data points. If it's something else, then there was a mistake. Okay, so we are missing one data point. Let's see which one we are missing. I see. So here what I have to do is just use less than, so it doesn't subtract that first data point. So what it did is basically subtract the first data point, and that made 119. Now that we got that fixed, now I would like to calculate the chi-square value. The formula to calculate chi-square value for the goodness of fit test is the expected minus observed whole square divided by the expected value. That is the chi-square. So let's type that equals parentheses expected minus observed, close the parentheses, whole square divided by the expected value. Copy all the way down. So these are all my chi-square values for. So the total chi-square value, sum of all of this individual chi-square value. Now I need to get the degrees of freedom to calculate the probability from the chi-square value. I'm gonna just type df. Degrees of freedom from chi-square is the number of cell minus 1. So I have total 8 cells. However, I'm not gonna type 8 because in case if I choose to run this analysis using another cell size, then if I can just change this cell value and then everything else will be changed automatically. That's the degrees of freedom. Now I would like to calculate the probability p-value using the chi-square distribution. So I can say there is a function called chi-sq dot dist dot r. It's going to give me the right tail probability. That's the p-value I'm looking for. X is the chi-square value, degrees of freedom. Let's see. So this is the p-value, probability value of this test. Now I would like to do a 4-step process in hypothesis testing. So let's write that 4-step process of hypothesis testing. Step number 1 is the hypothesis, which is null hypothesis. Is the data is normally distributed. Alternative hypothesis would be the data is not normally distributed. This is the step number 1. Step number 2 is the method of the test. We apply chi-square goodness of fit test. We're just trying to see whether this data set fits a normal distribution. Step number 3 is the result. I would like to write the result this way. So let's write the result. So we do not reject the null hypothesis because the p-value, I would like to put the p-value within the parentheses. P-value is larger than the level of significance, which is alpha 0.05. Now step number 4 is the contextual conclusion. So basically the emission data, carbon dioxide emission data is normally distributed. That's about the objective test.